Hello everybody, today's video is about dividing polynomials. Most of it will be on polynomial long division except this first example. So in this example we're dividing 4x cubed plus 10x squared plus 3x by 2x squared. So essentially we've seen this before in 7th grade. So if we just write it like this, it might look more familiar. And even to make it easier, that 2x squared can actually be split up to divide every single term individually. That's in the numerator. There we go. And so now we just go one by one. So 4 divided by 2 is 2, x cubed divided by x squared is x, plus 10 over 2 is 5, x squared divided by x squared is 1, so we're going to leave it at 5. And then 3x over 2x is, oops, that's supposed to be an x squared, sorry about that. 3x over 2x squared is 3 over 2x because the x's cancel each other out, leaving 1x on the bottom. And so here's your final answer. So it looks a little weird because you have like a whole number fraction, but that is how it's supposed to look. Before we go on to the next example, I want to give you a little reminder from the past, a little blast from the past. If we were doing this as a long division problem, we could do this, and we could divide 2 by 2 and get 1, and then bring down the 3 and get 1 again. And then here we have a remainder, which, after 5th grade, we pretty much just kept going and made it a decimal to 11.5. However, if we did not keep going, you'll notice that we get the 1, we bring down the 3, we get the 1, and we have a 1 left over. What we could do is use that remainder 1, but instead that remainder is divided by 2 because of that. So we can write 11.5, which is exactly what the answer is. Okay, so what you can do with the remainder is write it as the numerator over the divisor. So that's what we're going to do in the next problem. So now we have 2m squared minus m minus 3 divided by m minus 1. We're going to set this up as a long division problem because if you factor the top, it's not going to have anything in common with 2m minus 1 if the top is indeed factorable, which I think it is. So here we go. We're going to do 2m squared minus m minus 3 divided by m minus 1. So what we're going to do is just, if you look at the first terms here, what would you have to multiply m by to get 2m squared? So you'd have to multiply by 2m. Similar to that long division in the past, now we multiply these two things together. So we get 2m squared, which we wanted to get in the first place to get rid of that. And then we also have to distribute this 2m to the negative 1, so we get minus 2m. Now when we subtract, remember, subtract in parentheses because this subtraction's got to affect not only this but also this. And so 2m squared minus 2m squared is 0. But then negative m minus negative, so this ends up being addition. So negative m plus 2m is m. And then we're going to, just like before, bring down the next term, minus 3. So now we do m into m, so that's just 1. So we're going to say plus 1. And then use the distributive property on m minus 1, so we get m minus 1. So again, put that in parentheses. So we get negative 3 minus negative 1, so it's negative 3 plus 1, and then m minus m is 0. So now we're left with this negative 2, which we're just going to put as the remainder over m minus 1. So we just say minus 2 over m minus 1. So there's your final answer right there. Okay. Let's look at this one. So this is relatively similar. The only thing different is that if you notice it's in standard form, but it's missing a z squared term. If it's missing a term, that means it has a 0 coefficient, essentially. We need to put it back in there. So I'm going to write this under a division bar here. 18z cubed plus 0z squared, because there are none, minus 8z plus 2. We're going to divide all that by 3z minus 1. So 3z goes in 18z cubed, goes in 6z squared times, and so we multiply that. We're going to get 18z cubed minus 6z squared. And when we subtract, we're going to get plus 6z squared. We're going to bring down that minus 8z and continue. So 3z goes into 6z squared twice, 2z times. So now we do 2z times all of that, so 6z squared minus 2z, leaving us with, remember that's all subtracted, so negative 8 plus 2, so negative 6z, bringing down the plus 2, and finally 3z goes into negative 6d, negative 2 times. Now we have negative 6z plus 2, and we're subtracting all that. Okay, so was that right? Did I make a mistake there? So let's take a look. Negative 6z plus 2, and this will be negative 6z plus 2. Okay, so we are subtracting it, and so that is going to make it 0. So here's our final answer with no remainder this time. And finally, for our last example, it's very similar to the last two, except it is not in standard form. So we need to put it into standard form by putting the exponents in descending order. So first thing I'm going to write is 6y squared, then I have a minus 10y, and then I have a minus 7. That's going to be divided by this 3y plus 4. Or positive 3y and positive 4. Okay, so 3y goes into 6y squared, 2y times, oops. So we want this to be 6y squared plus 8y, and we are subtracting this. So we get negative 10 minus 8, so negative 18y. Bring down the minus 7, and we have 3 times negative 6. 3y times negative 6 is negative 18y. So negative 18y minus 24. And remember, that's all being subtracted. So this goes away. And then we have negative 7 plus 24, which is what, 17? Okay. And that's the remainder, so we're going to say plus 17 over 3y plus 4. Alright, so this doesn't really occur as often as the factoring when you're working on math problems and placement tests and things like that, but it is something that comes up from time to time. So thanks for watching.